So today's section 5.4, this one's about things being mutually exclusive. Do you remember hearing the words mutually exclusive? Hi. So do you guys remember mutually exclusive being used before? If you have two events that are mutually exclusive, or disjoint, when we talked about the Venn diagrams. So this just means if something is mutually exclusive, it means two things that cannot happen at the same time. So, for example, if we've got a new litter of puppies is born, so the puppies might be different colors. You can have combinations of colors, but the puppies could be male or female. These are two mutually exclusive events. A puppy cannot be both male and female. It's impossible. But you could have brown and male. These are not mutually exclusive. So you could have a brown puppy that's male. So mutually exclusive just means two things that cannot occur at the same time. So since a puppy could be both brown and a male, so this one said it's not mutually exclusive. Whereas if two events cannot occur, so male and female, this is what we call mutually exclusive. Mutually. So you've seen this before. This should be just review from the previous chapter. Was it chapter 4 or chapter 3? I don't remember which one it was. I think it was chapter 3. So we've seen mutually exclusive. This is if we're looking at Venn diagrams, which these ones you've seen before. So this one where they're disjoint, this is where you have mutually exclusive. So I don't want to write all that out. I'll just put ME, mutually exclusive. So this is mutually exclusive because they cannot occur at the same time. So this would be the situation where this circle will include the males, this circle would include the females. These cannot happen at the same time. Whereas this one would be not mutually exclusive because this would be the puppies that are brown and the male. Yeah.
So mutually exclusive means it can't be both things at the same time?
Mutually exclusive means they cannot. They're separate, yeah.
But mutually exclusive, not mutually exclusive means it can't be both.
Yes, yeah. So, for instance, if we talk about the class, if we talked about a student being in foundations of math and pre-calculus, that would be mutually exclusive. There's no student that is in both pre-calc and... Yes, 11 minutes. Yeah, we started at 12:40.
I was sitting downstairs in next to Mom.
Yeah.
And I was alone with 2 other people and we didn't realize the time.
It's okay. You're not the only one who was. Today there was no bells or anything.
Yeah, there's no bells and there's no teachers outside.
Yeah, I don't know who was supposed to be out there. It's the first day back. That's when everyone. That's been the excuse of today for all the classes. So again, if they're disjoint, if you cannot have a overlap, it's mutually exclusive, and if there is overlap, it's not mutually exclusive. And this is going to be important in this unit when we talk about probability. So can we come up with other examples that are mutually exclusive? So could you think of something else that would be mutually exclusive? So what would be another set of events that would be mutually exclusive? I don't have them printed. I can print them after the lesson if you want. I don't have them because we started them
You
online.
can't have green and pink hair and one head of hair.
Yeah, you can.
Right.
You can dye your hair.
You can dye your hair half red or half
Oh.
each color.
Ew.
It's tricky. So two things that cannot occur at the same time. So we could talk about.
Oh, yeah, boys can't be bears and girls can't be
Perfect. That's the part that you missed before class. So it's like you were here mentally. How about an object being a square and a triangle?
plus 4 half 3.
So these are mutually exclusive. I cannot have a shape that is both square and triangle. What else?
You want the other?
Can you think of any other?
Not be an arm.
Hands cannot be arms. Okay, we're going to debate definition.
Can't be a foot.
There you go, hands and foot.
Yeah.
So a body part cannot be both a hand and a foot in most cases.
An insect can't be
Uh-huh.
a mammal.
Yeah, insect.
Water cannot be fire.
Good. So what elements? So an element cannot be both water and fire. Good. So these are different things that we would consider as mutually exclusive. It might seem very childish to try and think of this, that of course there's two things that can't be the same, but once you try and think of what they are, it's quite difficult until you still start to get on a roll. Like a 4 cannot be a 5, stuff like that. So this is now going to come into play when we talk about probability, because we need to look at, are these things mutually exclusive or not? Because that's going to determine how many positive outcomes we have. So remember, just as a reminder for probability, so probability is going to equal number of positive outcomes over total outcomes. So just as a reminder of what probability is. So in this case, we want the probability of drawing a heart. So we have a deck of cards. What's the probability of picking a heart or a black king?
How many hearts are there?
So there's
One.
yeah, so there's 13 hearts.
And 16 on the.
And how many kings are there? There's 4 total, and how many of them are black? 2.
So 15.
The question is, can a card be both a heart and a black king? No,
Yes, no.
because hearts are red.
Red.
So there's no way that you can have a red black king. So these are mutually exclusive. So therefore, the number of positive outcomes is going to be 13 plus 2.
Why do you add?
Because it could be hearts or king. So anytime we're dealing with or, you're going to add.
And 52.
Yeah, and the total is there's 52 cards in the deck. Good. So then you can plug this in your calculator.
28%.
Yeah. I think I got 28.8%.
Did you divide it? So you divide it.
Yeah, you just plug this in your calculator, you'll get a decimal and then times by 100.
2 by 15.
Yeah. So I personally like putting it as a percentage. If you wanted to do fraction, decimal, that's fine. I don't really care as long as you put it as a percent or as a probability. Okay, let's try this one. So find the probability of drawing a heart or a face card. So are these two things mutually exclusive?
A heart or face card. What's a face card?
So King, Queen, Jack.
There's 12. Okay.
So there's going to be 12 face cards
And there's 13 hearts.
and 13 hearts. But can I have a heart that is a face card? right? I can have a king of hearts, I can have a queen of hearts, and a jack of hearts. So if I were to look at this, these are my hearts, and if these are the face cards, I'm going to have 3 that are in the middle. It's like the last unit, and we're adding this. So if there's 3 in the middle, that means there's 10 hearts here, there's 9 face cards left over here. So in total, 10 plus 3 plus 9. Over, again, the total number of cards is 52. And yeah. I'm just going to leave this as a fraction for this one. You can put it into a percent if you want. I'll just leave it like this. So you'll notice why I said last unit was really important, because we're taking the stuff from last unit and now just dividing it by the total. So it's nice. It's kind of a review of last unit. Any questions on these two so far? Yes, the completed notes are up online already, and the blank notes are up there too, and then I'll post the video as well. Yeah, I switched, so there was a set of completed notes up online that wasn't the exact same as this. So I went and changed them so they're all the exact same, they're just smaller. Prefer you sit on the chair. Sure. So now we want to find the probability of rolling a sum greater than 8 or doubles with 2 regular dice. So regular dice meaning 6 sides.
More than 8?
Yeah. So this one is a little bit more tricky for you to do in your head. So when you get to something like this with dice, what I suggest is you make a table of results.
Just draw the die.
Yes, but we need to look at what are the options when I have a 1 and a 3, 1 and a 5, 1 and a 6, 2 and a 3, 2 and so on. So if I have, wait, let me make this. So 1, 2. The computer adjusts it a tad bit, I think.
Wow.
Okay. So when you're doing this one, we're looking for a sum, so let's just start adding these. So this box would be if I have a 1 and a 1. So this would be a 2, this is a 1 and a 2, so 3, 4, 5, 6, 7. I'm going to quickly fill this in. 3, 4, 5. That's why I'm doing this without actually, I'm not actually adding anything. So in this, let's look at 2 things.
The question is very straightforward. Now I understand, because when you read it, it wasn't that.
And I would be able to explain that on a test if you didn't understand what that meant. So that's fine. So let's look at all the answers here, or all the results that are greater than 8. So 9, 9, 9, 9, 10, 10, 10, 11, 11, and 12. So there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 greater than 8. And then rolling doubles. So 1 and a 1, that's a double. 2 and a 2, 3 and a 3, 4 and a 4, 5 and a 5, 6 and a 6. So there's 1, 2, 3, 4, 5, 6 doubles.
Wait, what? What do you mean rolling a double?
So rolling a double means they both have the same value. So if you roll the dice and both of them have a 1, that's a double. Or 2 3s or 2 4s. That would be rolling a double. So are these two events mutually exclusive? Can something be greater than 8 and also a double? Yeah. I have 5 and a 5 and a 6 and a 6. Those are included in both of these. So this one is not mutually exclusive. So I've got an overlap region. So it's good to know that just for when I'm counting this. You don't necessarily need to know this to answer it, because I can just say the probability is and then count. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So 14 positive outcomes over 36 total. Do the calculation. I just left it as a fraction. So this is 7, 15, 16, 17, 18. I think that's as simplified as you can do it.
2.5.
Flip it. So 7 over 18.
2.5.
You shouldn't get 2.5. That decimal is way too small. 7. It should be 7 divided by 18. Yeah. And then times it by 100, you get the percent.
So 7 divided by 18.
Times 100 will give you the percentage.
Yes.
So whenever whenever you are given a question that involves the sum of two dice, most often you're going to have to quickly draw this out. And I take that into account with the timing, because it's really hard to see all the results unless you have them written out. So just as a little tip, that's something that's really important to know. Any questions with this, or that makes sense? You're good? Okay. I think this is
Yeah, I understand now. Then when
good.
so weird. Because I get, the problem is I get when I read this thoughts when I read this stuff.
And it's often really easy to. Do you make? So dyslexia is when you mix up words and letters and numbers in your head.
Yeah, there's like a math type of dyslexia.
Yeah, which is when you mix up numbers.
I think I have that.
I have test anxiety, so I can understand to be so good with them. And then second, the test paper comes in front of me, I get every single thing, and I can.
I think about 50% of the students here have test anxiety.
Like,
No, it's not understand
you
something.
didn't
I
test.
just forget everything.
Yeah,
Like I'm not anxious often at all. I just forget.
you know,
Like,
when
I can't.
I get so scared, and then, because I'm head and whatever, I had a test, and I slept.
Wow.
Just because of how scared I was to do the test, I wasn't able to focus. And then the secretary was sitting there, he was like, "Are you okay?" And I was like, "Are you good?"
Why are the classes longer?
Because this is the normal schedule. We're not on the Ramadan schedule, so the classes are longer.
No. Oh. So Mr. Al was
Let me finish this one example, and then we're done with the notes today, I think, and then I can go through it. So in North America, the probability of being left-handed is about 10%, and the probability of having red hair, I'm guessing this is going to be natural red hair and not dyed red hair, is about 6%. The probability of having neither of these is 85. What is the probability that a randomly selected person will be a left-handed redhead? So this is a lot of information, and this is hard to do until you find a Venn diagram to represent this. Because once we can figure that out, it's not too tricky. This is actually a question from not last chapter, chapter 3. So let's make a Venn diagram here. So this is going to be the universal set. And I need to draw two circles. The question is, are these two things mutually exclusive? So I've got someone being left-handed and red hair. You can have both. So this is not mutually exclusive, meaning what? Correct. Yeah, so like think of exclusive. If something is exclusive, you can only have that thing. Not everyone can have it. So you can't. Mutual means like these. Yeah. So together, exclusive. It's like a little bit of an oxymoron. Yeah. Yeah. So let's say this is left-handed, this is redhead. So what are we told in this question? So we are told the probability of someone being left-handed is 10%. So that means this whole thing, this whole circle is 10. So I can't put it here because it also includes this. Same thing with red hair being 6%. The probability of having neither is 85. So 85% is outside.
Wait, does it not come the inside have to be 50%?
So that means these three sections need to add up to 15, yeah. So the number in...
It's 10 and 6. See, this is what confuses me, because the numbers are bigger than these are really explicit.
Exactly. So let's think about that. If I've got the number of left-handers is 10, the number of redheads is 6. If I add those two together, what do I get? 16, which is how many bigger than this? So then, if left-handed total is 10, yeah, so 10 minus... Yep. And let's double check this, because if I put these numbers back in here, 9 plus 1 plus 5 gives me that 15. So 10 was left-handed total, minus the middle gives us just this section. Left-handeds only are 9. Red hairs total are 6. I take away the middle, so that gives me only redhead is 5. So what's the probability? It's going to be... It's in percentage form already. So it's already in probabilities. We don't need to do anything. So it's 1%.
So the difference between the outside and if the inside doesn't work, so then we put in the middle?
Yeah. There is an equation for it, but I find if you can just logically reason through it, it's pretty straightforward.
Okay, so if the number, so if say left-handed is about 10% and redhead is about 15%, so it's 25% and the outside is 85. So the difference is 10. So you put the 10 in the middle?
Yeah. But in this, yeah, and that's how you do that. Because this is the equation. So
Okay,
number in L.
When you take away 10, 15 from 10, no, you take away 10 from 15 and 10 from 10. So it's going to be a 0. You got what I'm talking about?
Yeah, and that's just because your numbers are, the way you pick the numbers don't work. So this was, yeah, yeah, and that's just because of the numbers being picked, but your strategy is correct.
Can it all be the same?
You can, but then you have 0 here.
Yeah, you're going to come to okay.
Yeah, and
Water.
yeah. So this is the equation for it, and you can plug that in. So you would get number in L is 10, number in the red is 6, minus this middle section, which is what we want, equals the number in both, which is 15. So doing algebra, you'd be able to figure this out and get the 1 here. Because you'd have 16 minus this center region.
What's the L and
Left-handed and red hair. So 16 minus what gives you 15?
Or something, and then like I
That's why I didn't give you this. I tried to just reason with you in your head.
Okay.
And that's the notes.
So I have a question.
Mm-hmm.
I have two tests, but I haven't gotten them.
Yes, we can talk about that. So the practice problems for this are from the notes, just so you, it's not from the textbook for this one.